Welcome to An Introduction to Relational Databases, an educational video offered in conjunction with EasyPHPWebsites.com, your go-to guide for making the most of the PHP language. My name is Jason Gilmore, and in this video I'll introduce you to the concept of a relational database using the popular MySQL database to demonstrate key concepts. As always, if you have any questions, be sure to email me at jason@easyphpwebsites.com. Explaining the importance of a relational database is best done by describing the precarious situation you'd find yourself in as a developer if the concept did not exist at all. Suppose you were building a website which will manage your growing video game collection. The website consists of just a few simple pages, including a page for viewing a list of games according to platform, and pages for adding and updating games. For purposes of discussion, suppose the data was managed within a simple delimited text file. The form used to add a game looks like this. As you use this form to add new video games to your collection, inconsistencies begin to arise. For instance, at first you diligently type the publisher's name in its entirety, entering Electronic Arts, for instance. However, over time, variations such as Electronic Arts, eArts, and sometimes just EA start to creep in. Further, when entering the platform, Xbox 360 becomes Xbox 350 due to mistyping, and even worse, sometimes just Xbox, which conflicts with one of your older consoles. By introducing these inconsistencies, the ability to view games according to publisher or platform becomes nearly impossible. Also, you might consider a scenario where you owned multiple copies of a game such as Madden Football 2009, including the Xbox 360 and the Nintendo Wii versions. One day you realize that you've incorrectly entered the price for the Nintendo Wii version, and using some sort of edit interface, you want to modify the price. But what happens when you submit these changes? How will the site know which row in your text file it should modify? Should it modify the Wii version or the Xbox version? You might apply this dilemma to a company's human resources database or website, in which, for example, you're trying to adjust the salary of an employee named John Smith. Well, what if there are three John Smiths employed at your company? The question really is, how are you going to be absolutely certain the right row of data, the right line that is going to be updated? Even worse, what if the system updates the salary for all three John Smiths? These are the sorts of endless problems that you'll encounter when you are tasked with modifying even a small amount of data. All of these sorts of inconsistency problems can be resolved by managing your data within what's commonly known as a relational database. Relational databases can resolve these inconsistency problems by organizing data into a set of well-defined units, such as games, publishers, and platforms, and then interrelating that data using these unique identifiers known as keys. In this example, each table has a key named ID. Because these keys, referred to in this case as primary keys, must unequivocally be unique in order to ensure the row is unique, typically you'll see the columns defined as an incremental integer. That is to say, each time a new row is inserted into a table, the new row's primary key value is equal to the previously inserted row, that is, its primary key value plus 1. For example, the publishers table shown in the previous slide would look like this after a few rows have been inserted. This practice of using incrementing integer values as primary keys is so commonplace that most relational databases, MySQL included, offer some level of built-in support for performing the incremental process for you. For instance, instance, this is what the publishers table creation syntax would look like in MySQL. Now we're able to uniquely identify each row in a table using this primary key, giving us the ability to reference primary keys from multiple tables in order to interrelate data. When these primary keys are referred to from within other tables, they're known as foreign keys. In this diagram, I've highlighted the two foreign keys found in the video games table. Using these foreign keys, we can create the video games table, mapping the rows found in the platforms and publishers tables to each game. With this structure in place, we can revise the game form so it looks like this. In the revised form, drop-down menus are available for both the platforms and the publishers, thereby forcing the user to choose from a predefined list that has been created from the platforms and publishers tables, rather than just wing it and type in this information or some variation thereof. If you look at the source code of the revised Game Edition form, you'd see HTML that looks like this, in this case, which is used to construct the platform menu. As you can see, the value for each option is an integer, and that integer happens to be the primary key that corresponds to the related, in this case, platform in each table row. In a nutshell, relational databases are a very powerful concept thanks to this practice of organizing data within well-defined tables and then interrelating that data using primary keys such as integer values. I do hope you've enjoyed this introduction to the thinking behind a relational database. If you're watching this video in conjunction with the book Easy PHP Websites with the Zen Framework, I suggest continuing with your learning by reading the next chapter and watching some of the other videos. In particular, check out the video introducing database normalization, which is a perfect follow-up to what you've just learned. If you're not familiar with easyphpwebsites.com, come on over and check us out. In addition to free videos, you can learn more about my two latest books, including Easy PHP Websites with the Zen Framework and the best-selling Beginning PHP and MySQL, now in its 3rd edition. Thanks, and I'll see you soon.